Now, sorry, for some reason my recording stopped in the middle, so I'm just going to go back to the beginning as well. Again, this is the third question, and it's to do with graphs of trigonometric functions. So they've shown a sine graph here, starting at 0 and going up and down between 1 and -1. So we know the range of it. The range is from -1 to 1. And it's the graph of sine of 2x, so we know the period is going to be divided by 2. So it does a complete waveform between 0 and 180 degrees instead of just between 0 and 360 degrees. The graph here made the markings in terms of pi in radians. So if you're more comfortable with it, you might decide to mark in the degrees straight away. It's also useful to maybe put in these points. So this is halfway, that's 90 degrees, and that's going to be 270 degrees. And you could go even further and say that's 45 degrees, but you don't need all of this, depending on the questions that are asked. That's 180 plus 45, 225. 225. Right, then they also have the line, which is intersecting the graph at several different points, and the line is called 2y equals 1. Well, we can see that that's the same as calling this line y equals 0.5 or half. So dividing across by 2, we get y equals 0.5. Okay, on the same diagram above, sketch the graphs of sine of x. Okay, so sine of x has a range, the same range, from -1 to 1, but the period is 360 degrees. So it looks nearly identical, except it's stretched out. So where's the halfway point? The halfway point is here, which means that my sine function is going to come to a peak here. Okay, I don't even have to use an input-output table. You could, but you don't need to. And then down as far as -1 here. And it's going to come up to 360 degrees. Okay, that's a little bit patchy, so we can go over it and make it a bit clearer. You can rub out any extra bits of lines when you're happy with a smooth curve. It should look something like that. Now I would, in this case, go over it in a color or with a highlighter, because they've asked us to indicate clearly which graph is which. So this is the graph g of x equal to sine of x, like that. And then they also want us to do the graph of h of x, which is 3 times sine of 2x. So this one, the range is going to change and go from -3 to 3, but the period, because it's sine of 2x, is going to be 180. So it's going to be identical to this guy, except it goes up higher. It goes up all the way to 3 and down all the way to -3, and everything else is the same. So the wave function is just coming up that bit higher and going down that bit lower. And again, you don't need to do an input-output table. You're just showing that you understand how the shape changes when you multiply the whole function versus when you multiply the angle. Okay, and again, I'll go over that in a color just to make it nice and clear. But you don't want to spend too long on these. If I was doing an input-output table, I probably would end up going over the time. So they're really expecting that you understand the shapes of your trig graphs here. And I'm going to clearly label it. This one's h of x equal to 3 sine 2x. Now, the next thing they ask us to do is to find the coordinates of the point P. Okay. So we're looking for a point of intersection. We're looking for a point of intersection between f of x equal to sine 2x and y also equal to f of x, y equal to a half. Y equal to a half. So we're looking for the values of x when sine of 2x is equal to a half. That's what this question is asking me to do. And this is very like the first question we did now. So we are going to draw our unit circle. ASTC, sine is positive in the first and second quadrants, and we're going to go through all of this. So my reference angle is sine inverse of a half, which is 30 degrees. So 2x could be these two values here. And then I look at my quadrants. So 2x could be 30 degrees, which means that when I do my general form, 2x is 30 degrees plus n times 360, and x is 15 plus n times 360. Second quadrant, 2x is equal to 180 minus 30, 150. General form, 2x is equal to 150 plus n times, I keep forgetting to divide my 360. I'm writing it down again, n times 360. So that means that x, hopefully me making that mistake is going to make it less likely that you guys will make that mistake. I don't know why I'm doing that today. N times 180. And then I fill in, n is equal to 0. X will be 15 or 75 when n is equal to 1. X will be 15 plus 180, 195. 75 plus 180, 255. And I don't have to go to n equals 2 because my graph stops at 360, stops at 2 pi. So which of these values matches P? Matches the point that we were asked for. Let's look at our graph. So looking at our graph up here, we can see that my line, y equals a half or 2y equals 1, this line intersects at 1, 2, 3, 4 different points. This one here would be my 15 degrees. That's the first value, the smallest value. This one here would be my 75 degrees. And if you look down on the x-axis, that makes sense. That's 15, that's 75. Yeah, that looks right. This is my third value, 195 degrees. And this is my fourth value, 255 degrees. So this is P. So my answer here is that P is the point when x is equal to 255 and y is equal to a half. Now you should get full marks for that. However, because the graph is done in radians, I would convert 255 into radians. And how do we do that? We multiply by pi over 180. So that's going to be 255 divided by 180, 17 pi over 12. 17 pi over 12. So another way of writing exactly the same answer would be that P is 17 pi over 12, that's the x value, comma, a half. So either answer there should give you full marks. The marking scheme writes it in radians because it's matching this, but because the question didn't specify that you needed to give your answer in radians, you can give it in degrees, just clearly indicate that it's in degrees. Let me just zoom out onto that whole page there so that you can see it in one go. It's probably a bit too zoomed out. And that's the solution there that you need. Okay, thank you.